What was the V-2 rocket's gyroscopic guidance system? Imagine a missile flying across the sky, steering itself with incredible precision for its time. That's what the V-2 rocket achieved with its gyroscopic guidance system. This technology was a major step forward in missile control during World War II. It helped the rocket stay on course during its powered flight, which lasted about 60 to 70 seconds. The system used two main gyroscopes that spun freely. One was positioned horizontally to control the pitch, which is the up and down movement. The other was vertical and had 2 degrees of freedom to manage yaw, or side-to-side movement. These gyroscopes constantly tracked the rocket's orientation relative to the Earth. If the rocket started to drift off course, the gyroscopes detected the change. They sent electrical signals to small control surfaces, like graphite rudders and vanes in the exhaust. These surfaces then adjusted the rocket's direction, steering it toward its target. This active correction only happened during the powered phase when the liquid-fueled engine was burning. Once the engine cut off, the rocket followed a ballistic path without further course corrections. The guidance system also included a device called a pendulous integrating gyroscopic accelerometer, or PIGA. This device combined a gyroscope with a suspended mass that acted like a pendulum. It sensed acceleration forces during flight and integrated these signals over time to calculate the rocket's velocity. When the rocket reached a set speed, the PIGA sent a signal to shut off the engine. This marked the transition from powered flight to free fall. The system also had a simple analog computer that processed signals from the gyroscopes and accelerometer. It coordinated the control surface adjustments to keep the rocket on its intended path. There were attempts to use external radio signals, like the Lorentz beam, for navigation, but these were unreliable and abandoned. This gyroscopic guidance system was a pioneering form of inertial navigation technology. It allowed the V-2 to be the first long-range guided ballistic missile in history. Its accuracy was limited by the technology of the time, with a circular error probable of about 25 kilometers. That means the missile could land within 25 kilometers of its target, often due to atmospheric conditions during its unpowered descent. In summary, the V-2's guidance system combined free gyroscopes for orientation sensing, a gyroscopic accelerometer for velocity measurement, and an analog computer for control. It enabled the missile to steer during powered flight and then coast ballistically to its target. This system marked a major milestone in missile guidance during World War II and laid the groundwork for future navigation systems.